Glad we have your attention. Our company has patented a machine that removes rusting. No chemicals needed. The machine removes all rust. My associates and I will explain to you how this chemical reaction works.
Here's the unbalanced equation of rust you find if you just Google rust equations. In order to balance this equation, there needs to be equal amounts of iron and oxygen on both sides of the equation.
So here you need to get equal oxygen, and there's 3 on the reactant side and 2 on the product side. So you put a coefficient of 2 on the iron on the entire compound on the reactant side, and a 3 on the oxygen side on the product side. So there's 6 oxygen on both sides of the balancing equation, and thus oxygen is satisfied. Here you also have unbalanced iron now, so there's 2 coefficient and 2 subscript on the reactant side of the iron, and there's only 1 iron on the right side. So you have to put the coefficient to 4 on the product side, so that there's 4 iron on both sides, and thus iron is satisfied.
Decomposition, because our machine takes rust, which is a compound of iron and oxygen, that separates them so that they produce iron and oxygen. It shouldn't be harmful or dangerous to the environment because the machine doesn't run on any resource and only produces iron and oxygen.
So if we needed to find out how much oxygen would be produced from 160 grams of rust, we would go through this equation. So you'd start off with 160 grams of iron and oxygen, which is the rust equation, over 1, and then you multiply it times 1 mole of iron, and then you, on the bottom of the fraction, you'd put the molar mass of iron or of rust. So you have 319.347, and then from there they would remove each other, the grams and grams, and then you'd have 1 mole of rust and then over its molar mass. In order to eliminate the 1 mole of rust, you'd need to multiply it by a fraction which on the bottom has that same mole of rust. So here is you get 3 moles of that of oxygen over 2 moles of rust if you are trying to eliminate that. And then this is what you end up with from this and this. You end up with 480 grams divided by 638.748, and you'd get that your amount of oxygen produced from rust is 0.7514 grams of oxide. So this is Ramon and Nathan, and take care.